Let's find some real zeros of this polynomial. We are going to be using the rational root or rational zeros theorem to get our list of possibilities. That means that the rational roots are going to be the factors of the constant divided by the factors of the lead coefficient. And that means our universe of possibilities consists of all the factors of 12 divided by the factors of 1. Remember, when there isn't a number in front of it, it has a coefficient. It's just that the coefficient is 1. So factors of the constant will be 1, 2, 3, 4, 6, and 12 itself. I'm going to just abbreviate the fact that all of those are plus or minus by putting a single one of those out in front, and then divide by either positive or negative 1. Thank goodness the lead coefficient is simply 1, and so its only factor is 1. So when you have a lead coefficient of 1, it means that all of your possible rational solutions are themselves integers, because when you divide by 1, you're never going to form a fraction. So really, we're looking at all of these integers up here. Those are that's like our universe of possible rational answers. So we're going to check the very first one. We'll check 1 with synthetic division. The coefficients of this are 1, minus 5, 2, and 12. So 1, minus 5, 2, and 12. Mix up the colors so it's easier to see. Bring down the 1. 1 times 1 is 1. Negative 5 plus 1 is negative 4. Times 1 is negative 4. 2 minus 4 is negative 2. Negative 2 times 1 is negative 2. And this becomes 10. So that's bad. We don't want that. Let's test negative 1. Divide by negative 1, same coefficients as before. Copy the 1, negative 1, negative 6, 6, 8, negative 8, and 4. So this likewise is a great big frowny face. That means the 1s are out. They can't possibly be it. I don't want to scribble out the plus or minus. So the 1s are out. Now let's test 2. Divide by 2. Come on, we got to hit a good one sometime. 1, negative 5, 2, and 12. 1, 2, negative 3, negative 6, negative 4, times 2 is negative 8, and that's 4. Another bad one. Be consistent with your colors. Negative 2. Divide by that. 1, minus 5, 2, and 12. Copy the 1. Negative 2, that becomes negative 7. 14. 2 plus 14 is 16. 16 times negative 2 is negative 32. And that becomes negative 20. So no luck so far. Wow, this really stinks. Okay, that means we have gotten rid of the 1 and the 2. And we're also out of room. So I have to make some space here. We will now be testing the 3. Once we find even one hit here, it's going to immediately make our job like super easy, because what we can do is turn it into a quadratic. As soon as it's a quadratic, we no longer have to do synthetic division, because then we have a method that will already solve it for us, quadratic formula. So let's check the 3. If we divide by 3, 1, negative 5, 2, and 12. 1, 3, negative 2, negative 6. That's negative 4. Oh, look at that. Lighten up like a Christmas tree. Woo! Okay, so we found the one that we want. Now, what this means is that x cubed minus 5x squared plus 2x plus 12. Always keep in mind what your results actually mean. It means that this is equal to x minus 3 times, and then I'm going to write the result of the division, x squared minus 2x minus 4, where this comes from here. These numbers actually do mean something. They're not just randomly scribbled numbers. So the remainder of, well, that's the wrong word. The rest of the solutions will come from the solutions that this has. Once you get into a quadratic, now you can solve it with quadratic formula or factoring. Can this factor? Let's see, 4 and 1 could get us a 4, but 4 and 1 can only get us either a 5 or a 3 in the middle. And that's not what we need. What about 2 and 2? Well, 2 and 2 can either get us 4 or 0, and that's not what's in the middle, so we're going to just have to use quadratic formula. So for this, its solutions are x equals, yes, you can sing the song if you want, negative b plus or minus square root of b squared minus 4ac all over 2a. And this is 2 plus or minus square root of, that's 4 plus 16, yes, plus, over 2. 4 plus 16 is 20. 2 plus or minus root 20 over 2. And root 20, a 4 comes out and becomes a 2. So this is 2 plus or minus 2 root 5 over 2. Reduce that, and it's 1 plus or minus square root of 5. So find all the real zeros. They are that x equals either 3, that's from this factor right here, or 1 plus root 5, or 1 minus root 5. It's fine to write them in a list and just include that single time that you write it with the plus minus sign. Simple, right? Well, you know, anyway, not impossible.